Hey everybody, welcome back. We're talking about Chapter 10, Lesson 5, and this is all about using probability in our everyday lives. The main focus of this is to use probability to make decisions and predictions, and that's exactly what our learning target is. I can use probability to make decisions and predictions. First thing that we really need to know is that these decisions and predictions, we solve them and figure them out by using proportions, just like we did back when we learned percents originally. The other way that we can use this, I'll talk about in a second. First, let's look at these through an example. Let's say that we had a Major League Baseball player who has a batting average of 0.331. And over the course of the next 4 games, we want to know how many times is he going to get a hit. And we want to assume there are three at-bats a game. So to figure this out, the first thing we need to do is figure out how many total at-bats. And to do that, we just take 4 times 3. So total at-bats equals 4 times 3, which gives us 12 total. Now, to figure out how many we expect, or the expected value, we can do either way that we mentioned. 1, set of proportion, or 2, use the formula. And I will talk through that in a second. To set up the proportion, we take our fraction, or our probability, which is 0.331, and convert that to fraction. So we have 331 for every 1,000 attempts. And we set that equal to whatever we think is going to happen, so our expected value, over our total, 12. So our total is coming down on the bottom. And then we solve. So in solving this, we want to get x by itself. So we multiply both sides by 12. So do times 12 times 12. Because we do it on one side, we have to do it on the other. So we multiply everything out. So we have 331 times 12. So we get 266 and 3,310, adding those together. So we have 3,972 on top, and 1,000 is still on the bottom. So 3,972 over 1,000 equals x, and then we simplify to get 3.972 equals x. So we expect 3.972 at-bats. Now the formula is how this works out when we look at things in the end. This 331 over 1,000 is equal to 0.31, and this 12, that is our total. So our formula is going to be expected value equals the probability times our total. So if we do that in this problem, we would take 0.331, multiply that by 12, and that's going to give us the same value of 3.972. Our first example in our notebook today looks at a at a restaurant and they're trying to figure out how many customers are unsatisfied. The table below is a survey of 500 customers, and that is supposed to be representative of their 240,000 total customers. We need to use this information to figure out how many unsatisfied customers there are. First, we're going to set it up using the proportions that we had learned previously, followed by comparing our answer if we had just used our formula. So we're going to take the total number of unsatisfied customers, 35, and the total number of customers, 500. So we have 35 over 500, which is the same fraction as 7 over 100, and gives us a probability of 0.07. So from there we can set up our proportion. So we have 0.07 is the same thing as 7 over 100, and we're going to set that up so we have the number that we're trying to find, x, the number of unsatisfied customers, over the grand total number of customers the restaurant has, so 240,000. And then we would solve. We multiply both sides by 240,000, so we get 7 times 240,000 equals 100n. And when we take 7 times 240,000, we get 1,680,000, and we divide that by 100. So we get 16,800 unsatisfied customers. And this will work every time. Now, we could have sped this up a little bit by doing 0.07 times 240,000. And if we do that, we get the same answer as we had before. Now our second example for the day looks at using probability to figure out whether or not a game is fair. This is something you already have a little bit of practice at from what we did on Friday. In example 2, we have a game where two players each flip a coin. Player A wins if exactly one of the two coins is heads. Otherwise, player B wins. Determine whether the game is fair. So just like we were doing before, we want to list all the possible outcomes. So we get heads heads, heads tails, tails heads, and heads heads. Now to add a little bit of data to this, let's write down next to them what the outcome of that would actually be. Who wins, player A or player B? So with heads heads, player B wins. Heads tails, player A. Tails heads, player A. And tails tails, player B. So that means when we look at player A winning, so the probability of player A, we count how many times they won. 1, 2. And that is out of a total of 4 different outcomes. So 2 out of 4 equals 1/2. And there are exactly 2 ways for exactly one of the 2 coins to land on heads. Now for player B to win, we do the same thing. They have 2 ways of winning out of 4 possible. So we get 2 over 4, which is the same as 1/2. And those two fractions are the same. So because of that, because the probability of player A winning is the same as player B winning, the game is fair. And that is all we need to know in order to judge whether or not a game is fair. Do both players have the same outcome of winning? Now, tonight's homework is page 560, 6 through 14. In your textbook, there are also problems on page 558 and 559 that are further examples that help you out. And just to recap, there are two things. First, set up a proportion. Or, two, use our formula. And for that formula, we had expected value equals our probability times total. And that is all that I have for today. Hopefully you did well on your quiz, and I will see you all later, if not